Okay, filled up with our 365 roughly bits of polystyrene, labelled and dated, as you would think. Now we get our ammonia, crack the lid so it's fresh, and we pour our ammonia in. Now ammonia, of course, is unusual in itself. It's highly alkaline, hyperalkaline, extremely alkaline, in other words. That's what I'm saying, if someone doesn't know what that means. Extremely alkaline. And the reason it's extremely alkaline is the unusual property of, and we should get exactly, I'll just fill this upside down, spill it too much, because being extremely alkaline, you don't want to get too much on your fingers. It's not going to burn that much. Well, it's only very dark, it's extremely alkaline, but it's not, it's not fuming or something like that. And hopefully we should get very close. Yep, there we go. I've done it again, haven't I? Filled it all the way up. But put your lid on it, and you got your known quantity of thing, and you can start shaking it about. I usually give it about 200, and you'll get some of this through and through, sort of thing. It's because it's a gas, of course. It's a molecular gas. In other words, it's more than just one atom joined together, sort of thing. And it has the unusual property that 80 parts of ammonia gas can go into 1 part of water. In other words, you could have 80 cubic centimeters of ammonia gas, pure ammonia gas, can go into 1 cubic centimeter of water. So if you have like a litre, or if you have like 2 litres, a 2 litre bottle, how much gas can you get into a 2 litre bottle? Well, you could get 160 litres bottles worth of pure gas into that 2 litre bottle. I suppose that you will change the volume slightly, I suppose. To a certain degree, you will change the properties of the water, and you will change its density and things like that. As you can see, the actual phosphorus is now going quite easily throughout those, throughout the interstices between the polystyrene, which themselves probably have interstices, micro-interstices in. So if an organism wanted to get some phosphorus, it could easily get some phosphorus, you know what I mean? If these particles can get between those polystyrene voids or interstices, on the molecular scale, on the atomic and molecular scale, they can easily go through. Those gaps are like chasms, if not, even bigger than that, distances between planets, basically, probably. So eventually, over time, it will probably all settle on the bottom, and so on and so forth. So basically, what I'm saying is, you think, the ammonia is going to come off very easily. Not necessarily, because it's got such as I said, it's got the greatest solubility of any known regular gas, I suppose, or basic gas that's been discovered in the last 200. I'm sure there's probably some rare special ones coming out of some laboratory somewhere in the world, Livermore or somewhere else. I've read about making really, really heavy gases by reacting noble gases with certain things, using special catalysts and things like that, and lasers and things like that to make things go together that normally wouldn't go together. And I think that was in the levitating spoon, or the Flostrian spoon, or something like that. I've forgotten what the name of the book was. It was something or other spoon. It talked about all these sort of oddball sort of elements. It was quite interesting. But anyway, what we're going to do now, I'm going to take it over here, and I'm going to set it up. Off camera, I'm going to keep shaking it and do the 200 properly and be consistent. And I'm going to put it over here in this sun bizzo down here, I think. So it's next to that one there. So basically, the only difference between that one and that one is the ammonia. So that's got no ammonia. It's just polystyrene and a bit of phosphorus, a known quantity of phosphorus. This is a known quantity of phosphorus, polystyrene, and just made up with your household $1.50 ammonia sort of thing. And we'll see, and I'll inoculate it with our cyanide and our red organism over there, and which has a fly on it at the moment. Interesting. Going for a bit of supper, are we? Was there something in there he knows what we don't? Okay, so I'll inoculate that, and that one went green overnight. But now, I don't know. This is hyperalkaline, so maybe we're going to attract some of the extremophiles. Might find that is an extremophile, but only in certain things. Maybe like extreme, pH, but it doesn't like extreme salinity or something like that. It may be, you've got to make this assumption that some extremophiles only like certain extremes. They don't like all the extremes. You don't like, I've got to have it really salty, I've got to have it really alkaline, or I've got to have it really salty, really acid. Maybe they just like certain extremities, or think, I like it really alkaline, but I don't like any salt, which is hard to do, because how do you make it alkaline? Or maybe they like it really alkaline, but I don't like any sodium, so you can't use sodium hydroxide, because you could use a little bit of sodium hydroxide and make it super alkaline very quickly with a very small amount. But you might find the organism says, I like the alkalinity, but I don't like any sodium. And there's some important reason why it doesn't like the sodium. So yeah, it will only grow in this, and it won't, if you take a small quantity of sodium hydroxide and put it in your bottle, it won't grow, sort of thing, even though it's extremely alkaline. Don't know, that's what we're going to learn, I suppose, over time. But look at this, it's like hanging shit, isn't it? Maybe that's what I call the title of this one. Yes, maybe this is the one. Okay, but okay, we'll see how we go. And of course the sunlight's getting on those ones, so we'll see if we get any sort of reaction. But that one's interesting. That other earlier one we did is actually losing its blue colour, but it's not going green, as far as we know anyway. I mean, it should be a nice lime green, according to the amount of copper that I put into that one. Anyway, we'll see how we go. I'll inoculate this one, and I suppose if it's any better than that one, it should go green, get that sort of greenish tint overnight. Basically, because what I've got now is 2 out of the 3 of the NP, 2 out of the 3 of the NPK triangle. You got the nitrogen, you got the potassium and the phosphorus, but out of those 3, we've only got the nitrogen from the ammonia. And we got I suppose we have got a bit of calcium in there, as I said, mentioned another inconsistency of the using your rock phosphate sort of thing. It's got calcium in there, and CPs aren't supposed to like calcium. Yet I found it to be one of the better phosphorus sources for your CP sort of thing. Other things I've noticed too, like with the potash and things like that, are they actually putting a bit of copper into your potash, or is it just they're not making it as well as they do? I just got the impression from some of these experiments I was doing that there's something wrong with the potash. Are they actually putting copper into potash or something? I don't know. Interesting. Got a fly in there already. Okay. See you for now, I think. Can't think of anything else to say. For you, Richard, that's just absolutely bloody amazing. Okay. See ya.